Okay, so we spent a couple days learning how to take a derivative, learning what the derivative is, how to use the derivative. Let's look at the graphs and compare the graphs now and think about what they mean. Now remember that f of x, our original equation, is going to be the height. Okay, how high is our parabola? Whereas f prime of x, our derivative, is going to be the slope or the gradient. Okay, so this is telling me what is the gradient over here at a certain value. So if we look over here, when x is 1, it looks like the slope is going down. Okay, looks like it's going down. I don't know how fast, I don't know exactly what the slope is, but it is going down. It is going to be a negative slope. Well, if we look over at this graph, it'll actually tell me what the slope is. Okay, so if I come to x is -1, where's my y value? My y value is down here at -2. Okay, so my slope here at -1, is -2. What is my slope when I'm at the very bottom? It should be about 0. Let's look at this graph. Well, I'm looking at my x value, so here's x's. At 0, it is at 0. Okay, it's the height of 0. So my slope right here, m is 0. How about over on this side? Okay. Well, over there, if we come over to 1, looks like we are at 2. And if you look, it is pretty steep. That's probably pretty accurate. All right, let's try a problem now. I have the derivative here. The derivative is always f prime of x is 3. So if we drew a graph of that, it would just be a solid line right here at 3. Now, our actual graph, f of x, we don't know what the actual equation is. It starts somewhere down here. What would the graph look like, though? That's what we're going to be doing. What does the graph look like if my derivative is always 3? Well, remember, this is my slope. Okay, that's my slope. Is the slope changing, or is the slope going to always be the same? Well, it looks like the slope is always the same. The slope is always 3. So if I come over here, if the slope is 3 right at 0, that's pretty steep. Okay. As I keep going on, it's still 3. Still 3, it's still 3, it's still 3, okay? Still 3, still 3, still 3. That's roughly what the equation would look like for the graph. Let's do another one. Now, I can't stress enough, the derivative is the slope, the gradient, whatever word's going to stick in your mind, okay? I'll even write gradient up here for you. That is the verbiage that they use in IB, is that the gradient is slope, but they just use gradient. They won't ever say slope. All right, so as we're looking at this one, something interesting is happening right here at x equals 2. When x equals 2, our derivative is 0. Now, remember, what is the derivative? The derivative is our gradient. If the gradient is 0, if the slope is 0, what would the line look like at that point? Okay, so we're over here at 2 somewhere. Let's say our 2 point is right here. If the gradient is 0, think, what would that be? What would that be? Wouldn't that just be flat? It's not going up, it's not going down. The gradient is just flat, okay? So basically, it looks kind of like that, right at x is 2. I don't know where this is exactly going up and down. But now I need to look over here. If I am left of 2, so as I go further left, the gradient is positive. Now here's where it would mess a lot of people up. They're going to think positive, oh, I should start going up. Well, if we think of this slope, is that a positive slope or is that a negative slope? That is a negative slope. So that's not what it's going to look like. So the line is going to be coming up to reach here. okay? Then everything after that point, it looks like we are in the negative. So it starts going down after we've hit that flat spot. Okay, that's roughly what the graph will look like, moving it up and down. So if you notice something really special right here, when you've got that 0, that is going to be either a maximum, okay, in this case we had a maximum, a high point, or a minimum. Can you see that? Yeah, you can see that part way over there, okay? So whenever your derivative f prime of x equals 0, you have a max or a min. All right, on this one, if you notice, it touches 0 twice, our derivative does. So our slope, okay, our slope is saying that we're going to have two max or min values. They might both be maximum values, they might both be minimum values. We don't know. So let's just put on 2 points here. Let's just do them here and here. We're just drawing right now. We're not necessarily trying to draw the exact graph of what this was. We're trying to visualize what is happening. So we see that it is positive to the left. The slope is positive. That means the slope is rising to meet that point, okay? So the slope has to be going up till we get there. Then the slope starts going down, okay? Starts to become negative. So this point right here probably is even in the wrong spot. So if the slope starts going down till we get to down here somewhere, okay? That's where we're hitting 0. We're flat again, okay? We're flat, then it's positive, so it comes up like this, okay? Okay, so let's look at these 3 equations here. We want to know what is the maximum or minimum value on those graphs. So what we can do, if we can figure out where the derivative is 0, so where f prime of x equals 0, if we can figure out where that x value is, that's going to tell us what the maximum or minimum value, where the maximum or minimum value will be. Okay, let me show you what I mean. So here, if I take the derivative, f prime of x is going to be 6x minus 6, okay? And I figure out where this is 0, that's going to either be the highest point on the graph or the lowest point, all right? So if I want it to be 0, well, I'm going to add 6. That gives me 6x equals 1, divide by 6, divide by 6. That gives me 1. Sorry, I jumped ahead and got 1. So x equals 1 is the x value where either I'm going to have the bottom of a parabola, see the parabola is going to come down, and at x equals 1, it's either going to be the lowest spot or it's going to be the highest spot. That's what's happening at 1, okay? That's what this is telling me. All I have to do is just figure out what the value is, how high or how low it is. So here we go, let's give it a try. I take 3 times 1 squared is 3. 3 minus 6 is negative 3. Negative 3 plus 5 is 2, so y is 2. So the highest or lowest point, in this case lowest, if you notice the 3 is positive, so it's going to open up. It's going to be an opening up parabola. The min value, relative min, is going to be 1, 2. Okay? Let's try the same thing here. If you notice, this is also going to be a positive. It's going to be opening up. You can tell because this first number is positive. So if it opens up, that means that we're going to have a minimum value. We're trying to figure out where the minimum value is. Well, let's take the derivative. G prime of x is 4x plus 4, minus 4 from both sides, if that equals 0. It gives me 4x equals negative 4. Divide by 4, x is negative 1. So I'm going to take that negative 1, plug it into here. It's going to give me 2 minus 4 So 2 minus 4 is negative 2. Negative 2 minus 9 is negative 11. So the low value on this graph is negative 1 comma negative 11. Try this one real quick. That's my min value. Try this one real quick. What is it going to be a high point or a low point? What is that point? Pause the video if you need to. All right, you should have paused the video. I'm going to show you the correct answer now. So first thing we need to do is determine, is this going to have a relative maximum or relative minimum? Okay. So as I'm looking at the graph, well, it's a negative 8, so it's going to be opening down. It's going to look kind of like this. So this is going to have a highest point on the graph. So we go through, we take the derivative. H prime of x is negative 16x plus 4. I want to figure out where that's 0, so I'm going to subtract 4, gives me negative 16 equals negative 4, divide by negative 16, divide by negative 16. That gives me x equals 1/4. Whew! Let's go through and finish this. Okay, so I'm going to plug 1/4 in, so that's going to be 1/16, so that's negative 1/2. Here, 1/4 times 4 is 1 plus 12, so our y value is going to be 12.5. Okay, so this point right here, the highest point on the graph, is going to be 1/4, comma 12.5.